Welcome to S&D College of Engineering and Research Center online lecture series. Today's online lecture on engineering physics, unit first, wave optics. In wave optics, you will study interference, diffraction and polarization. In interference, you can also learn subtopics. First one is introduction to electromagnetic waves and electromagnetic spectrum. Let's see what is electromagnetic wave. Electromagnetic waves are propagating couple of an electric and magnetic field. They are hence known as electromagnetic wave. The production of electromagnetic waves does not require any medium. The electromagnetic wave propagates in the medium totally of their own. The electric and magnetic field vector are at angle of 90 degree and both are perpendicular to direction of propagation of wave. In electromagnetic wave, electric field and magnetic field travel perpendicular to each other. In this figure you can see in red color there are electric fields, in blue color magnetic fields. Electric field traveling on x-axis and magnetic field traveling on z-axis. An electromagnetic wave can be created by accelerating charges. Moving charges back and forth will produce oscillating electric and magnetic field, and this travel at the speed of light. Electromagnetic wave travel as vibration in electric and magnetic fields, have some magnetic and some electrical properties to them. You can see how to travel electromagnetic wave. When an electric field changes, so does the magnetic field. The changing magnetic field causes the electric field to change. When one field vibrates, so does the other. Let's see properties of electromagnetic wave. They are transverse in nature. They can travel through a vacuum. They travel at the speed of light in vacuum. Electromagnetic wave follows the principle of superposition. Next, electromagnetic spectrum. What is electromagnetic spectrum? Electromagnetic spectrum is the categorization of electromagnetic wave according to their wavelength and frequency. Electromagnetic spectrums are categorized their wavelengths and their frequency. The behavior of an electromagnetic wave in a substance depends on its frequency or wavelength. Name of the range of electromagnetic waves when placed in order of increasing frequency. Increasing frequency. First one is radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-rays and gamma rays. The behavior of electromagnetic wave in a substance depends on its frequency or wavelength. You can see wavelength of radio waves is larger than gamma rays. Notice the wavelength is long, get to shorter. Notice longer wavelength to shorter wavelength. Longer wavelength is radio waves, microwave, infrared, visible, ultraviolet, X-ray and gamma ray. Shortest wavelength is gamma rays. Radio waves have the longest wavelength and lowest frequency of all the electromagnetic waves. Radio wave has longest wavelength and lowest frequency. Properties of radio wave. Radio waves are used to communication such as television and radio. Radio waves are transmitted easily through the air. They do not cause damage if absorbed by the human body, and they can be reflected to change their direction. This property makes them ideal for communication. Second, Global positioning system means what? GPS. Measure the time it takes a radio wave to travel from several satellites to the receiver. Determine the distance to each satellite. In radio waves used to determine the distance to each satellite. MRI, magnetic resonance imaging, uses short wave radio waves, uses short waves length has radio waves with a magnet to create an image. Second one, microwaves. Microwave has the shortest wavelength and highest frequency in the gigahertz range of the radio waves. As compared to radio waves, microwave has frequency highest frequency. Properties of microwaves. Microwaves are used for cooking food and for satellite communication. High frequency microwaves have frequencies which are easily absorbed by molecule in food. The internal energy of the molecule increases when they absorb microwave, which cause heating. Microwave pass easily through the atmosphere, so they can pass between stations on Earth and satellites in orbit. Used in microwave ovens. Microwave are used in ovens. Waves transfer energy to the water in the food, causing them to vibrate, which in turn transfer energy in the form of heat to the food. Radars, radio detection and ranging, used to find the speed of an object by sending out radio waves and measuring the time it takes them to return. Next one is visible light. Visible light means visible range. The wavelength is 4000 degree angstrom to 7000 degree angstrom. Electromagnetic waves we can see. Longest wavelength is 7000 degree angstrom in red color, and shortest wavelength is 4000 degree angstrom in violet light. Infrared rays. Infrared, below red, shorter wavelength and higher frequency than microwave. Infrared has shorter wavelength and higher frequency than microwave, and range is below than red. Range is below than red. In properties of infrared, infrared light is used by electrical heater, cooker for cooking food, and by infrared cameras which detect people in the dark. Infrared light has frequency which are absorbed by some chemical bond. All objects emit infrared light. The human eye cannot see this light, but infrared camera can detect it. This thermal imaging is useful for detecting people in the dark. Visible light. Visible light is the light we can see. It is used in fiber optic communication, where coded pulses of light travel through glass fiber from a source or to receiver. Brief summary. All electromagnetic waves travel at the same speed, 3 into 10 raised to 8 meter per second in a vacuum. They all have different wavelength and different frequency. Long wavelength, lowest frequency; short wavelength, highest frequency. The higher the frequency, the higher the energy. I hope you have understood this. Thank you.